All right, I'm here with 52 weeks of exploring languages, this time still on Julia, playing around with Julia. And I'm going to just get right into it and dive into more Julia stuff. We'll share the screen. Here we go. Julia. All right. And getting started here, I think we got into function piping on episode 4, which is definitely interesting. Let's start off from there and keep going. So I'm gonna go to my code space and just open this up and get it cooking. Yeah, what is cool about GitHub code spaces is for doing demos like this, it's hard to beat because it's a linking of the repository directly with the code that I'm actually building, which is pretty awesome. Okay, this thing is waking up. It is weird though how sometimes they take a while to start, sometimes they don't. It's hard to know what's actually going on. Okay, here we go. And we're inside of here. Welcome to this. There's new updates to Visual Studio. Great. And we're in the README. So yeah, last time I was into this, I guess I was looking at function piping, and we can pull that up again. So functions in Julia can be combined by composing or piping. And that is actually pretty slick. I don't think I went too far into details on this. Let me play around with this again a little bit more. And so if I go into this, we can type in Julia. There we go. Or actually, this is what I should be covering. That's right, because I'm on episode 4. So we didn't cover this. Okay, so I'm here, and I'll even put a note here. Like, here we go, Julia. Example. And that is pretty slick. You can pipe things together. And let's see, this is an example of 3 functions and maps the results over an array of strings. Wow, that's a lot of stuff to look at. And I'll just kind of play around with this. So you do a map function, and each one of these is a function. Okay, that's interesting. This is a little more interesting. So function chaining, which is more of a F# kind of style. And so I would put in 1 through 10, sum, square root. So first, let's see what that, let's break this up into pieces here. I mean, I like this. Let's do that. Let's just break, in order to understand like complex functions that pipe in other functions. When I've ever written code like this, I usually just run one at a time. So in this case, if I just grab this, we can just see what this does first. Okay. And with Julia, if you can just do type, something like that. What is that? What is 1 through 10? It looks like an array of some kind. What does that mean, 1 through 10? It's kind of, so we'll say Julia find type variable. How do we do this? Oh, type of. Okay, so there we go. We say, so I go type of. Oh, okay, so it's a range. I see. So it's a range 1 to 10, 64 Intel, 64-bit integer. So now the next thing I do is I get into sum here. There we go. Let's go into sum. Oh, okay, so I mean, that is actually that's pretty slick. I can't imagine it being less code than that. That's about as small as you could actually build something. And then you go through and you do a square root. So even if I was abandoning Julia forever and I thought it was the worst thing in the world, just this is actually pretty interesting. And so I could be nice to people and I could annotate this, right? I could say, let's break this down. Newbies. So newbies. So the first part is this is a range, right? So here, actually I don't do that. I won't put range like that. The next part is the am I bonking right here about what's the best way to document this? I would say Julia comments. Is it this comment? No. Is it this a comment? It looks like it works. So let's go through here and let's just break this down into pieces. So we'll say Julia range. Okay, that works. And then we'll say sum function that sums iterable slash range. That's the next one. This one. And if I do this, do sqrt function. And this one is square root function. That finds a square root. Square root. So that is cool. So if I was going to build something, I mean, I could then try something with each piece. Like I could go, I don't know, what's the square root of 1,000, right? And just make sure I understand how this works. 1,000, pipe it, and then go here and do sqrt. sqrt. There we go. That looks pretty cool. So I'll just put those in there for people so they can see, right? The example. And then if I wanted to use the sum, I could separately try that. I could do a different range, right? I could go and play around with, let's make it bigger. Let's make a bigger sum, right? Cool. And then, yeah, that's enough. That's enough to play around. Okay, I'm getting the piping thing here. This is I'm actually pretty impressed. Let's see what else. So this is another piping chaining. And so if I do, let's just again remind me, I guess it's a vector 4-element, right? 1, 2. Okay, it already tells us what the type is. So that's interesting. Wow. So each one separately is processed in the vector. Huh. Okay. So I guess I could run this individually first, right? So if I go here, 4-element vector string. Okay. And if I want to pipe it, go through here, pipe this thing. And I could, let's just start off with making them all do the same piping operation. So we'll just do that 4 times. Length. There we go. And each of them. So that doesn't work. What am I doing wrong here? So 1, 2, 3, 4. Or is it can be used with a broadcast to provide a useful combination. Oh, did I not do a dot? Is that I was missing a dot. So dot. So the broadcast would send each element of the array into each of these separate functions, which is definitely pretty cool. Wow, I like that. That's really slick. I mean, that's shocking, actually, how useful that is. Because again, depending on what I'm doing, like compare that to pandas. Pandas is not that straightforward, and so we'll put an example here that says podcast something like that. A little note that each of the elements is then sent to a separate function. That's pretty slick. And ooh, here we go. Dot syntax for vectorizing functions. So it's common to have vectorized functions that simply apply a function to each element of array. So this is true that if you wanted to do GPU programming in Python, you could use numba. And if you had a GPU available, you could write a vectorized function that could, in parallel do, a million calculations or something. And this syntax, or you could do it with pandas, right? Apply a function to a data frame. And so this kind of syntax is very convenient for data processing. That's correct. If loops are slow, the vectorized functions are very, very fast and they're low level. They're not required for performance, unlike R, pretty much everything you write in a vectorized way. Although you can do loops in R. In this case, it's beneficial to write your own loops. Therefore, any function can be applied element-wise to an array. Wow, that's pretty cool. So we make an array right here. And let's refresh this. Okay. We're going to, of course, do our type of thing to figure out what it is. As a vector. And then we can say the syntax is the function, the dot, and then, boy, this is like kind of Perl, like very, very concise, but powerful. So there we go. We applied that function to every one. What happens if we want to try the square root? Ooh, pretty cool. We want to do the sum. Happens. There you go. Nice. So pretty cool that you can do vectorized functions. So we'll put a little comment there for vectorized functions. Vectorized functions. Thanks. Okay, so next we put the docs there, and then we have inside of here this and this. So wow, that is definitely makes me want to do some cool stuff. And so what I could do is let's write a little script. And so I could say touch vectorize experiment.jl. Okay? And let's just see if we can play around with this and go to make a, let's go through here. Let's make an array. There we go. So inside of a script here, vectorized, let's do that. We can say clean around vectorized functions. Okay. And if we want to do the sum operation, that I was just playing around with, we can, or square root or whatever, we can go through here. Whoops. Go through here, square root. And I'm assuming the results, can just do this. Let's try that out in the shell. If I want to take this and I say results equals, does this work? Result. Okay, so yeah, it assigns it to there. So if I want to run it, I say Julia vectorize and print. If I remember correctly, is it like print ln or something like that? So 2 pages. Go through here. Print. Printf. I don't know if I want to do printf. Do I? Isn't there like a fancy print? Isn't there like a print ln or something? Print ln. Well, I guess print template. How do you do it? Print substitution, base print. That's good enough. Something like that. Oh no, println. Yeah, I thought there was a println. And you do, it just takes the word hello world. sprint. Which print do I care about? Well, let's not get lost in the weeds here. I'll just print. I need to learn printing better. But, there you go. We print out the result. And I guess if I said this, I said, where was the print again? Print line. We want to do something like that. Basic print. IO buffer. Print calls back to show. There's not. It's funny how there's not a perfect. Like I just want to substitute a variable and print inside of here, and it's trickier than I was anticipating. But I guess I could experiment and just see what happens. I just bring in like results. I don't know, and do result. I don't know what to do. Oh, yes, that works. But when in doubt, just mess around. Okay, so I got something. I wrote some code with vectorized functions. So definitely cool. And this is probably going to be a dense subject where I would really need to dig into this. And there's a lot going on. So finally, a maximum efficiency is achieved when it's pre-allocated. Adding dots to function calls can be tedious and lead to code that's difficult to read. The macro here is applied to convert every function call to an expression. So, interesting. I don't know if I understand that, but let's run it. Why not? Okay, let's run this code. Yeah, don't really understand it, but we'll blindly run it. Y. And then we got this right there. And then we do this. Not sure. Similar Y. Similar Y. Yeah, that's definitely dense enough. Like, Hmm. It's kind of like it does remind me of F sharp a little bit. You can also combine dot operations with function chaining. Yeah, this is, I think, as a mathematician or something, if you're going to, you're working on an equation for something, I could see how it could be pretty cool in terms of like you're writing production code and you're passing this on to somebody that you work with. It's like, thanks, like it it isn't complete. Maybe I'm changing my mind. I mean, it's not like this is make an array broadcasted to each of these separate functions. I guess that does make sense. And so if I break that down, I'm changing my mind a little bit. So if I do that, we'll change this to 2. We run this. Say I want to run odd twice. That work? Ooh, is odd. I don't know what that semicolon does. What does that thing do? Yeah, this is definitely like a particular part of the code that is worth, I mean, honestly, probably me studying multiple times, not just once. But it is interesting. I definitely learned some cool stuff. So I'll have to come back. But next week I'll go over control flow. So I'll put a note here that we say you didn't understand, you didn't fully understand. Right, so we can look for myself. Hey, you can get this. And then we'll go through here. Episode 5 will cover control flow. There you go. All right. Okay, so I'm done here, and I'm going to call it a day for today. Thanks for the one person who showed up and for the hint, and I'll see you next week.